Welcome to the last part of the third part where we're going to do two examples of advanced trig graphs. So let's do this cosecant graph, and we can approach it in two different ways. The first way is, either way, I'm going to start with the table, but I'll kind of show you a different approach. Let me get through one first. So I think to myself, cosecant is the reciprocal of the sine. That is a table I know backwards and forwards, right? We're going to do 0 pi over 2 pi, 3 pi over 2, and 2 pi. The sine of x starts at 0, goes to 1, back to 0, down to -1 to 0. But this is a cosecant graph, not a sine graph. So that means I have to take their reciprocals. Next, I notice in the parameters that my outside parameters are -3 and 2. They affect the y value. So I have to multiply by a -3. That was like not clear, is it? Come on, let's erase. I need to multiply by a -3 first by order of operations. Friends, the asymptote, it stays undefined. Undefined times something, plus something, minus something, it's still undefined. So this -3 is only going to really affect these two values. And then I'm going to add 2. And so that shores up what my y values are going to be. But I do have a phase shift. So that's going to affect the x. Anything on the inside affects the x in an opposite way. So on here, oh, that's already blue. I'm going to subtract pi over 4 from each of those values. So you're going to have to get a little bit of common denominator work, but trust me in that this is the hardest part, or the most annoying part, the longest part, the time suck of the problem. Well, 0 minus pi over 4 gets me to negative pi over 4. Well, in fourths, this is 2 pi over 4, so if I subtract 1 pi, I get a positive 1 pi over 4. This is 4 pi over 4, so if I subtract 1, I get a 3 pi over 4, and some of you might start seeing, might start seeing the pattern. All right, 3 pi over 2 in fourths is 6 pi over 4. Subtract 1, that gives me 5 pi over 4. And in terms of fourths, this is 8 pi over 4. Subtract 1, we get 7 pi over 4. Now you go graphing. If we look, we have asymptotes at negative pi over 4, 3 pi over 4, and 7 pi over 4. So at negative pi over 4, all right, at 3 pi over 4, so that's going to be a little bit past, so it's going to be past pi over 2. And 7 pi over 4 is going to be right, I almost made a mistake here. It's going to be right here. Then at pi over 4, I have a point at -1, and we know that those make that U shape. And then at 5 pi over 4, 5, which would be up here, all right, I'm going to be going this direction. And I'm done. You have, and some kids go, well, do you have to mark up the picture? I have a chart. First of all, you have graph paper where it's scaled, and I have all of the evidence that I need. So this is one way that you can go about it. Another way that some students go about it, perfectly legit, they still, even if they don't write it this way, they do think of their t-chart. They do think of x sine x. So you still have 0, pi over 2 pi, 3 pi over 2, 2 pi, 0, 1, 0, -1, 0. They still do all of the work. They multiply everything by -3 and add 2. All right, so they would multiply everything by 3. Sorry, a -3. And then add 2, that's a 0. And they're still going to do all of the work with their phase shift. So these values are not changing. So no matter how you slice it, you're still going to have to figure out those x values. But what they do instead is they draw the sine curve. So at negative pi over 4, 2, pi over 4, -1. Then at 3 pi over 4, they're back to 2. And then they are up at 5. And then they are back. Oh, I did, hold on, I have a mistake. That should be a -1. That's at 5, and then we're back at 2. And they notice that, okay, this is my sine curve. Okay, now that sine curve is not your final answer. I'm just drawing it in so you can see it. What they recognize is this is my midline, guys. Do you see how that is like my midline? So that at all of the points of the midline, I have an asymptote, and then I'm going to draw my U's at those max and min points. So the red represents my final answer. I honestly don't care how you do it. You don't have to do it like me based on a table, but I need evidence and I need details and I need it precise that I know where each of, I call it the 5 translated points. Where are the points that were on the original parent graph? Where are they showing up in your translated graph? So if you give me a table, I have all the evidence. If not, you are going to need to annotate pretty clearly your graph. All right, so here's our last one for today. And let's do a cotangent graph. So again, I'm going to start with my cotangent table. Unfortunately, really, cotangent and tangent don't work where you can graph one and kind of do the other like we did in the previous one. I'm just going to do x cotangent of x. So as a reminder, if you're sitting there going, I can't remember how to start it, go back to your unit circle. This is the point 1, 0. This is the point 0, 1. This is the point negative 1, 0. This is what I'm doing as a teacher while I'm teaching this on a video so I don't screw up. Well, if I do the x over the y, I'm undefined here and here. My cotangent is 0 at the pi over 2 and 3 pi over 2 locations. So my parent graph, remember we took that part, so that means I'm going to start at 0, I'm going to end at pi, pi over 2 is in the middle, and I pick pi over 4 because that family is very easy to compute cotangents and tangents. All right, so we have undefined, should be our borders for any cotangent or tangent graph for that matter. But remember, the cotangent of pi over 4 is a positive one. It's first quadrant, 0 and negative 1. So that's my parent graph. So now I look at 3 and negative 1. Those are my outside parameters. So I need to multiply by 3. Again, undefined is undefined. Then I need to subtract 1 from each of those values. Now, be very, very careful. Friends, you do not have a phase shift of pi over 2. That has to be factored. All right? So in order for me to figure out my phase shift, it has to be of the form b times x minus h. So we have to factor it. So I'm going to take this 3 and I need to factor it out so that I have a 1x. Well, the easy way to think about this is go ahead and when you're factoring out a 3, you're asking yourself what times 3 gets you 1/2. So what you really need is a third of pi over 2. So this is going to be pi over 6. And you can check your answer. 3 times x is 3x. 3 times pi over 6 gives me 3 pi over 6, which reduces to pi over 2. So we have to really think of this as the cotangent of 3 times x plus pi over 6. And we have a phase shift of pi over 6. Now, this is the first problem where we have had an issue where our period is not going to be the same as the parent graph. So remember what it means to be the cotangent of a multiple angle. What that means is if cotangent is periodic between 0 and pi, now I can fit 3 cotangent graphs. It's opposite. It's actually a shrink, not a stretch. Even though you think of 3 as bigger than a 1x, now I can get 3 cotangent graphs in that same space. So how do I do this with a table? That's your multiplier. We always deal with our multiplier before we deal with our addend. So I have to multiply by 1/3 by the reciprocal, not multiply by 3. So, or you can think of it as you're dividing by 3, you're multiplying by 1/3. So that makes this 0. That makes this pi over 12. So notice that this is just going to be ugly. Pi over 6, 3 pi over 12. And that's going to reduce to pi over 4, and we have pi over 3. Now, I'm going to have to subtract pi over 6 from each of those values. So again, this is the time suck. This is the part that isn't fun. All right, so this becomes negative pi over 6. pi over 12 minus pi over 6 is pi over 12 minus 2 pi over 12, which gives me a negative pi over 12. Pi over 6 minus pi over 6 is 0. That wasn't so bad. All right, 3 pi over 12. This is why I chose not to reduce it earlier, because it's already in 12ths. 3 pi over 12 minus pi over 6 is 3 pi over 12 minus 2 pi over 12. So that's a positive pi over 12. And last but not least, pi over 3 minus pi over 6 is 2 pi over 6 minus pi over 6, or a positive pi over 6. So what's happening in this graph, there is a whole lot happening in a very small space. So you're always welcome, if you want, you can always scratch out and you can always redo your scale. I never have a problem with that. If it's so small, cross out what's on your paper or whatnot. I'm totally okay with that. I'm just going to try to stay within the confines of the paper, and maybe I can, there we go, I can go in a little bit. Pinch in. All right, here we go. So to get my final at pi over 6 and at positive pi over 6, you're going to have your asymptotes. Then at 0, -1 is going to be kind of that middle. And notice pi over 12 and positive pi over 12 are really, really small. But I know that at negative pi over 12, I'm going to be at 2, so I'm going to be up here somewhere. And then at pi over 12, I'll be down here at 1, 2, -4 someplace. So that gives me like evidence of my stretch. And there's my cotangent graph. So again, if I had a student that said, the heck with that, I don't like that graph paper you gave me, I'm just going to go ahead and make my own, I'm totally okay with that. Especially if you're somebody who doesn't do a chart. I don't care if you write in negative pi over 6, negative pi over 12, pi over 12, pi over 6. I have asymptotes here. Negative pi over 12, I'm at 2. 0. 1, 2, 3, 4. And I don't care if you give me your own picture that looks like this. I just need to see evidence that you know that those are the 5 translated points. So hopefully this has been helpful. Come to office hours if you're stuck and you have a worksheet on advanced trig graphs due. Enjoy.